Welcome back again. So what we've done is we've just typed this out because unfortunately in the notes here you can't cut and paste this one because it's an image. So you can see that we've taken the code from page 84 and we've put that into our Conditional.c file that we created in the previous video. So let's just minimise this now. Right, let's try and run that. Mike, do you want to go do the honours on that?
Yep.
Okay. So we're in my C code again. Just remind us how we compile using GCC.
Okay, so we have a source file called Conditionals.c, and
we're in the right directory. Yeah.
Let's create an executable file called Conditionals.exe. So we want to call GCC, and we want to say that our output file wants to be called Conditionals, and we want to compile Conditionals.c. On there.
Okay, that looks good.
Have a quick look, and sure enough, now we have a Conditionals.exe file.
Okay, let's run it.
So let's run that. Enter two integers, and I will tell you the relationship they satisfy, which is obviously being printed from these two statements here.
Okay, let's enter two integers then.
What it's going to do is it's now scanning for two integers with a space in between, as you can see there, using the scanf.
So we need to get the text right for it to work, yeah.
So let's say we want to give me two integers, John.
10 and 11.
So we want to look at 10. Now put that space in, and 11. I press enter.
Oh, that looks promising.
You can see 10 is not equal to 11. 10 is less than 11. 10 is less than or equal to 11. So let's have a quick look at the flow of that then. So we saw that we printed out these two lines using the printf library statement, and which corresponds to these two lines here, and then the terminal waited for input of two integers separated by a space, and those two integers are entered and stored in these two values that into these two variables num1 and num2 using the address operator.
So just remind me again, Mike, because I'm a bit unclear on what that means.
Okay, this is sending to the scanf function the memory location, which is triggered by this ampersand here.
And if I just put num1, you told me this before, but tell me again.
The scanf function will be sent a copy of the variable, not the variable location. So the scanf function will not be able to return to you into those variables the entered.
So we'd effectively lose the numbers that we put in if we just pass to it num rather than at the address of num.
Exactly.
Okay, understand.
Okay, so then once we've entered those two values, they're stored in these two variable spaces, num1 and num2, and then we go through a array of conditional comparisons.
Okay, so let's just do one of those at a time.
Okay.
So on that top one there, we've got if num1 double equals num2.
Double
Why
equals,
double equals?
because using a single equal will assign a variable a value. Using a double equal will compare two variables for equality.
So if I put one equal in there, it would say num1 equals num2, and obviously that's true because I just said it, right?
Yeah.
So if I put num1 single equals num2,
actually
the result of that would always be true.
It would, because what you'll be doing is you'll be assigning the value of num2 into num1.
Yeah, which
So
would always be a true statement.
It would always
because
be a
I've
true
done it.
statement, and you'll end up with a runtime error.
Yeah.
Because you would have updated a variable num1 with the value of num2.
Yeah, yeah.
So you need to have the two to get the equality comparison.
Yeah, so this is logical rather than assigning. Yeah.
And so if the value stored in the variable num1 is equal to the value stored into num2, then we will print out.
Yeah, and that's where we see those curly brackets again. So just highlight those curly brackets. There's the curly brackets, and that's the bit of code it executes if num1 is equal to num2.
Yeah.
Brilliant.
Okay, so in this case it will print out the value of the number that you've entered.
Two values.
So we've entered 10 and 11, so our case here would not be true. So 10 is not equal to 11, so this code stored within these two curly braces would not be executed.
And just go down to the black window now, and so we don't see it printing.
We don't see it printing
num1
is equal to.
Yeah,
what we
because
see
it's not.
We printing is not equal to, which is actually the
Okay, that's the
second.
next.
So we haven't executed this piece of code because this conditional statement has not been satisfied. So what
Okay.
happened is the instruction pointer will jump down to here,
Okay.
and we'll look at this comparison. If num1 is not equal,
So the exclamation mark equal is not
negation.
equal, it's a negation.
it's a
Okay.
negation. So it's actually doing a comparison for equality and then negating it.
Mhm.
So in fact, what's happening here is if we look at this, num1 is equal to num2, this would be false.
Yeah.
So if we take false and we negate it,
Yeah.
we get true.
Yeah.
In so which case now this conditional statement is satisfied, so this line of code will be executed.
Yeah, and that's what we see
And that's
down
what
in
we
the
see.
command window, isn't it?
Yep,
So
10,
10 is not equal to 11, well, I guess we knew that, but we've got some code that tells us now.
And the same thing is going to happen for all the remaining conditional statements. So we have a less,
Yep.
this is less than, not less than or equal to. So
Yes.
in actual case here, and we can look at this again with another run of this. Let's just quickly do that. Let's run conditionals and let's put 10 and 10 in there.
Mhm, mhm.
Now we can see the output 10 is equal to 10. 10 is less than or equal to
Yes.
10. And 10 is greater than or equal to 10.
Yes.
Now the difference there is there's less than or less than or equal to.
Yep. Yep.
Greater than or greater than or equal to.
Gotcha.
And that is the conditional trigger points for those two statements. So it's inclusion of equal to in a greater than or less than comparison.
Fantastic. So I can use those if statements to actually switch in huge blocks of code. So inside that if statement, I can have a million lines of code.
Yes,
And,
we could put some extra lines. So if we take this 10 and 10 again, and we could add another printf statement in that block of code down here, and we could just write in here, they are the same. And we add another line of code in here. We have a new line at the end of it. We save that quickly. We recompile and we run, and then we put 10 and 10 in there again. Now I have
They're on the
two
same
lines
line.
of code
Yeah,
that are
yeah.
executed because they are within those curly braces. If I had to put that outside those curly braces, we would end up with a runtime error because we would see something executed on here that we didn't intend to happen, something
Yeah.
meant to happen.
Yeah. So the key things there, we've got the if statement, we've got the round brackets which contains the thing that we need to evaluate, and we've got the curly braces which tell us what code to run if in the event that that if statement is true.
And for completion, there is just one little thing we can discuss here. We have two printf statements consecutively placed.
Yes.
Why would we do that? The reason they've done that is simply because they didn't want it to trail off the end of the page.
Yeah.
What we can actually do is move this part here and include that in the same statement here and take this statement away, and this will give us exactly the same. Now why is that doing that? Because this /n, /n is escape character, is creating a new line for me.
Yeah.
So it's doing exactly the same.
But it gets a bit untidy, as you say, because
It
we end up
might
having a
run
very
off the
wide
page.
window open.
Let's just quickly prove that. We run that again and look.
Yeah.
It's exactly the same output. So there's no reason why you would want more printf statements like that consecutively apart from making it neat and tidy on the screen.
Okay, fantastic. So that's an introduction to conditionals as contained in page 84 and 85 of lecture 1 notes.